right, this video is for my pre-calculus class. We're actually going to be, this lab is to do trig identity proofs. And I'm not going to lie, it's my favorite. I love doing these. At the top of the page of the lab, you're going to see I've got some identities here. I have our reciprocal identities, which I had called in class your ugly cousins. Okay, so these are all the reciprocals. And you're going to use these a lot. And I always call sine and cosine my building blocks, because you can write, as you can see, every other trig function like tangent and cotangent you can write as sine over cosine or cosine over sine of x, and then cosecant is 1 over sine of x and secant of x is 1 over cosine. So all the other 4 trig functions can be written in sine and cosine. So I kind of call these my building blocks because those are the basics, and that's just something I call it, that everything kind of builds on those. So you get your quotient identities, you have your reciprocal, and then we have the Pythagorean identities. And again, if you see something squared, look over here. And remember, you can do these in different ways. You can solve for cosine squared, you can solve for sine squared, and you can move them around. So those are some of the basic identities. Now, to do tips for proving the identities is the first thing is you're going to work with a more complicated side. So I want you to look for the, I want to call it the ugly side. I use the word ugly a lot. The side that is more complicated, okay? I do not want you to do not cross multiply. Okay, so you're going to take one side that is the more complicated side, and you're going to use identities and algebra to figure out to make the sides match. So that's the first thing you're going to do is the complicated side. Then you're going to use your identities. And the identities are what I just showed you before. All the trig identities that you're going to need to do these will be here on this. So that's for number 2. And then 3, 4, 5, it says remove parentheses, find common denominators to add fractions, simplify complex fractions, and reduce fractions to lowest terms is all the algebra that you're going to use. So a lot of this is algebra we've already practiced, but now you're going to use it with trig functions. So I got a couple of examples to get us started here. I got example 1 and example 2. And I do have a lot of people who like to draw the line where the equal side is and just work on one side. It's totally up to you. I just want to make sure that you look at the complicated side. So here I see the left side is more complicated than the right side. So what I'm going to do is use some identities and some algebra to see if I can get it to match. So this is exactly what I do. I look at this, that's a building block, that's a building block, cosecant. Well, what is cosecant of theta? I come up here, cosecant of x or theta is 1 over sine. So I'm actually going to replace cosecant to 1 over sine of theta. So if sine theta times 1 over sine theta, that's cosecant of theta, minus sine theta, equals cosecant squared. So I don't want you using diddle marks. You're just going to keep writing equals cosecant squared till you get the left to match the right. Now I look at this, I'm going to distribute. I'm going to multiply this by sine theta and this by sine theta. Now, if it helps you, do sine theta over 1. If I multiply sine theta over 1 times 1 over sine theta, they cross out, or if you get sine theta over sine theta, that's just a 1, minus, and then sine theta times sine theta is sine squared theta equals cosine squared theta. All right, now I look at it and say, oh, I have a squared here. I wonder if that's an identity. So I'm going to come up here and look. Is 1 minus sine squared an identity? But I look at it and say, oh, if I move this over to this side and say, oh, cosine squared of x is going to equal 1 minus sine squared of x, I can move it that way. Then I can replace it right here. Okay, so 1 minus sine squared is cosine squared of x. And guess what? They match. So this is cosine squared of theta. This whole left side equals that, equals the right side. So I want you to write it like this. And then when they match, do a check mark with a line in it. Just saying you got the left to match the right, and that's how you proved it. You said it works. Now I'm just going to give you a hint. Everything on this lab works, so don't say it doesn't, okay? And when I say prove to see if they are identities, identities means the left and the right of your equation match. There, it makes it true. Okay, let's look at example number 2. If I look at example number 2, I have people who want to cross multiply. No, I see that the right-hand side is the more complicated one. So I'm going to play with the right-hand side to see if I can get it simplified. So I'm going to leave the left alone, 1 minus sine theta, and then I'm going to look at, is there something I can replace? And I know 1 plus sine theta, I can't really do anything with that because there's nothing squared, and that's a building block, but I have cosine squared. And we saw over here that cosine squared is the same as 1 minus sine squared, so I'm just going to replace it with 1 minus sine squared of theta. Okay, so now it's all in sine. Let's go to the next line. So I have 1 minus sine theta. We're going to keep playing and going with the right. And then I see, if I told you this was 1 minus x squared, you would see this is the difference of two perfect squares. So I can actually factor it by saying that's 1 minus sine theta times 1 plus sine theta, because it's the difference of two perfect squares. You're just now doing it with trig. That's pretty cool. And then the denominator is 1 plus sine theta. I'm going to put it in parentheses so you can look at it. And then you can say, oh, good, yay, thanks for playing. Those two divide to make a 1. So now I have 1 minus sine theta does equal 1 minus sine theta. So guess what? You proved that that identity works. So this is like the introduction video. Now I'm going to make another video that I'll do some of the problems in the lab to practice.